So now, before I explain this for part 2, this is part 2 of the video, I want you to start simplifying, let's say, I don't know, the square root of 26 divided by the square root of 3. Now, that's not simplified because there is a root on the bottom. You cannot have a square root on the bottom. 26 thirds cannot be simplified. So this is where it's called rationalizing the denominator. When a radical is in the denominator of a fraction, you can multiply the fraction by an appropriate form of 1 to eliminate the radical from the denominator. This process is called rationalizing the denominator. So here's what it means by an appropriate form of 1. I can take anything I want, anything at all, as long as you multiply the top and bottom by the same thing. Because, for example, let's just say I multiply by root 2 on top or bottom. I know that will not help me, but what does root 2 divided by root 2 give you? It gives you 1. I could multiply the top and bottom if I wanted to by x squared plus 5x plus 3 and x squared plus 5x plus 3. Now we have not even covered that yet, and that would make this enormously hard. But this right here would simplify into 1. That's what it means by multiplying the fraction by an appropriate value of 1. So here's what you got to think of. What can I multiply to the square root of 3? To give me a number that I can take the square root of. Well, if in my mind, I can multiply, like I can take the square root of 9. So then that means I can multiply the top and bottom by the square root of 3. So that gives me on the bottom the square root of 3 times the square root of 3, which is the square root of 9, which is just 3. Hence, you are going to get to notice this. Any root times itself gives you just that number. The square root of 5 times the square root of 5 is 5. The square root of 9n times the square root of 9n is 9n. It doesn't matter what you have, the roots they cancel. 26 times 3 gives me root 78. And that is simplified. So let's do some examples. Example 4, rationalize the denominator. We're going to simplify this. So, this is what I think of in my mind. What can I multiply to the square root of 3 to give me a number I can take the square root of? Well, I want 9, so I'm going to multiply by the square root of 3. But remember, I want my variables, when I take the square root, to always be even. So if it's odd, you just tack on a letter. So if you had n to the 5th, you would multiply by n. If you had n to the 7th, you'd multiply by n. If you had n to the 8th or any other even power, you would not multiply by anything. So I have to multiply the top and bottom by root 3n. That would give me root 15n divided by, now you can skip this step, but I'm going to show it to you. You would get root n, 9n squared. But that gives you the square root of 9n squared is 3n. I cannot simplify 15 thirds or the n's because one of them is underneath the radical and the other one is not. B, the cubed root. So what could I multiply by the cubed root? Well, 9, well, I think of 27. So what could I multiply by 9 to give me 27? Well, it's going to be root 3. I'm sorry, not root, cubed root 3. So that gives me 2 multiplied by the cubed root of 3 over the cubed root of 27, which gives me 2 cubed root 3 over 3. 2/3 cannot be simplified, so that's my answer. Now the binomials, a root b plus c root d and a root b minus c root d, where a, b, and c, d are rational numbers, are called conjugates. You can use conjugates to simplify radical expressions that contain a sum or difference involving square roots in the denominator. This is where, as a TAP student, you should see the similarity. This is not easy. I'm going to show you something here. You should already know this. If I said to multiply those two binomials, you should know that x minus 4 multiplied by x plus 4 completely cancel each other out. That means the middle terms are gone. You'd be left with x squared minus 16 because the middle terms cancel. The same thing is going to be true if you see this. 4 minus root 5 multiplied by 4 plus root 5. You have to make the association that you're going to FOIL these. Now the middle terms are going to cancel. Why? Because we're using the same properties as this. They are the exact same binomials, but one's a positive and one's a negative. So here we go. 4 times 4 is 16. Root 5 times root 5 is root 25, which is just 5. 16 minus 5 gives me 11. There's my answer. But if I gave you this, 4 minus root 5 squared, that'd be 4 minus root 5 multiplied by 4 minus root 5. You'd have to FOIL. 4 times 4 is 16. 4 times negative root 5 is negative 4 root 5. Negative root 5 times 4 is negative 4 root 5. Negative root 5 times negative root 5 is positive root 25, which is plus 5. That would give you 21 minus 8 root 5. You treat these just like terms. Negative 4 is negative 8. Now we're going to talk about this later, but I just wanted to show you what we're doing. Conjugates. Notice this. They are the exact same thing, except one's positive and one's negative. So in this example, we have 7 divided by 2 minus root 3. If you have a binomial, which we do here, you must multiply by its conjugate. The conjugate is taking the same binomial, but doing the opposite. So I have to multiply the top and bottom by 2 plus root 3. That means on top, you are going to get 7 times 2 plus root 3. That is a binomial. On bottom, you are going to get 2 minus root 3 times 2 plus root 3, which means 2 times 2 is 4. Minus root 3 times root 3 gives you minus root 9. You can skip that step if you want. Now, on top, that gives me 7 times 2 is 14. There's a 1 here. This is just like a letter. 7 times x would be 7x. 7 times root 3 is 7 root 3. You cannot add 14 plus 7 together. On the bottom, 4 minus square root of 9, well, that's 4 minus 3, which gives me 1. Therefore, my answer is 14 plus 7, root 3. Let's try another example. Let's do 12 divided by root 2 plus root 7. I would have to multiply the top and bottom by root 2 minus root 7. So I distribute the 12. That gives me 12 root 2 minus 12 root 7. On the bottom, I would take root 2 times root 2, which is root 4, which is 2. Root 7 times root 7 is 7. That would give me negative 5. So 12 root 2 minus 12 root 7 over negative 5. Now, if, let's just say, I got a 6 here, I would have to factor out a 12, and then you could simplify that with this. But we're going to talk about that later. Right now, that's just my answer. Two more examples left. Example 6. The distance d in miles that you can see in the horizon with your eye level h feet above the water is given to you by that formula. How far can you see when your eye level is 5 feet above the water? H stands for the feet above the water, so I plug it in. D equals the square root of 3 times 5 divided by 2. That gives you the square root of 15 halves, which gives me root 15 over root 2. Now, if I wanted you to simplify this in radical form, I can't have a root 2 on the bottom. So what would you multiply? We'd multiply by root 2, because I want to get 4. That gives me root 30 divided by 2. There's my answer. And if they did want the approximate miles, you could actually just take 15 divided by 2 and take the square root of that. It's approximately 2.74 miles. Example 7. The ratio of the length to the width of a golden rectangle is 1 plus root 5 to 2. The dimensions of the face of the Parthenon in Greece form a golden rectangle. What is h? So we can write a ratio of length to width. That would be 1 plus root 5 over 2 equals, let's see, length to width would be 31 over h. Or length to height, I should say. Cross multiply. H multiplied by 1 root 5. I'm sorry, 1 plus root 5 equals 62. H equals, divide both sides by 1 plus root 5. I get 62 divided by 1 plus root 5. But I have to rationalize the denominator. Oh boy. Not trying to make you feel like uh-oh here, but let's start multiplying. So what would I multiply the top and bottom by? It's conjugate. 1 minus root 5. That gives me, if I distribute the 62, you know what? I'm not going to distribute the 52 yet, or 62. On the bottom, 1 times 1 is 1. That'd be minus root 25, which gives me 62. That's not what I wanted to do. Multiplied by 1 minus root 5. Now, there's a reason why I'm not distributing that. Because this right here gives me 5. So 1 minus 5 is negative 4. Before I distribute, I can simplify this. So I can divide by 2. So that gives me 31 over negative 2 multiplied, and then on top, 1 minus root 5. Now I can distribute. 31 minus 31 root 5 divided by negative 2. So what is the approximate height, if you actually figured this out? Would be approximately 19 meters. The next example, we're going to talk about like radicals. Now, like radicals are just going to be like terms. Like 5x plus 3x is 8x. 5x plus 3y are not like terms. You can't combine them. So it's the same type of process. So, in A, I have 3 terms. The only way you can add them together is if they have the same or like radicals. So here I have root 7 and root 7. So all you do is combine the coefficients. So 5 minus 8 would be negative 3 root 7 and plus root 11. Now, if you can simplify root 11 or root 7, you would. We can't, and that's it. That's your answer. The next one, always simplify first if you can. 10 root 5. The square root of 5 cannot be simplified. Plus root 20. But root 20 can. I can break the root 20 up into root 4 times root 5. That gives me 10 root 5 plus square root of 4 is 2 root 5. And 10 root 5 plus 2 root 5 is 12 root 5. And there's my answer. C. 6 cubed root x plus 2 cubed root x would give me 8 cubed root x. That's it. That's all you do. And the last one. Root 5 multiplied to the binomial root 3 minus root 75. First thing we do is distribute. Root 5 times root 3 is root 15. Root 5 times negative root 75, that would be root, I believe it's 375, yes. All right, so now, root 15. This is where you have to think of, do any perfect squares go into 15? No. Do any perfect squares go into 375? Well, yeah. Root 25 times root, let's see, 25 goes 15. So now we simplify root 15 minus 5 root 15. Now, if there's nothing written in front, just like if you had an x, that's really a 1x. This is really 1 root 15. So 1 root 15 minus 5 root 15 is negative 4 root 15. And that's my answer.